So the last problem I want to address, which relates to sensitivity analysis, is the following. I'm told that I have the option to produce a new product, and this new product has a profit of $320 and requires, but to produce it, it requires 1 pump per unit, 8 hours of labor, and 13 feet of tubing. So I've already formulated my problem using only 2 decision variables, which were how much to produce from product 1 and product 2. Using the shadow prices of my original problem, I want to identify if it's going to be profitable to produce from this third product. Now, if I was going to construct a new LP that accounts for this new product, I would have done it as such. Maybe I'll add X3 as a decision variable, and I'll account for it in the objective function. It gives a profit of 320. It needs 1 pump, so I need to account for it in my pumps constraint. It needs 8 hours of labor and 13 feet of tubing. And accordingly, I have my new LP. But I would like to be able to, just using the sensitivity report, right, or the shadow prices, to be able to identify if this new product is going to be profitable to produce. So the question I want to answer is the following. I want to calculate the change in the optimal profit, the profit at optimality, if we produce one item, only one item of this new product. So if I produce, right, so if I produce only one new item of this product, I will increase my profit by $320, right, because it sells for $320. But it will cost me 1 pump, and I know that the shadow price of 1 pump is $200. So, and it will cost me 8 hours of labor, so 8 times the shadow price of labor, and it will cost me also 13 feet of tubing. So this will result in 320 minus 1 times 200 minus 8 times 16.67 minus 13 times 0, since the shadow price of feet of tubing is 0. And I will end up with a negative value of minus 13.33. So what this means is that forcing the system to produce 1 unit of product 3 is going to result in a decrease of $13.33. Now, we also refer to this value, right, as it's also referred to by the reduced cost. Right? So the reduced cost of item 3 at optimality is a negative value, right? So which, again, the reduced cost is defined as forcing the system to produce 1 item of this product at optimality. Since this is a negative value, it means it will not be desirable to produce. So without having to resolve the problem, I know that the optimal solution will remain as x1 star is 122, x2 star is 78, and x3 star is 0, since it has a negative reduced cost. Now, had you solved this problem and got a positive reduced cost, for example, if this is, I don't know, 400 instead of 320, the reduced cost will be positive. So your answer would be the following. It is going to be profitable. I know that if I resolve the LP, I will have a positive value of x3 at optimality, but I have to resolve the problem again. Okay? So maybe what you need to remember or to try to understand is what is a reduced cost? What's the definition of a reduced cost? A reduced cost at optimality of this new product is the change in the objective function value at optimality. If I force the system to produce only one unit of this product.